All right, today we're going to talk about and compare the properties of acids and bases. And we're going to do this with a Venn diagram, but we're going to talk about the properties of acids and bases first before we put them on the Venn diagram. So as you can see here, we have the pH scale. pH stands for percent hydrogen. And what we'll talk about is the fact that these acids and bases are all solutions that will fall into one of two categories. Either they will be an acid that produces a certain amount of hydronium ions in a solution. That's what makes an acid an acid. And when it produces those ions, the more ions it produces, the stronger the acid is. The less ions it produces, the weaker that acid is. For a base or an alkaline substance, we will have a pH above 7, and it will produce hydroxide, negative hydroxide ions in a solution. The stronger bases like bleach will produce lots of hydroxide ions, and they will be very strong electrolytes. The weaker bases like baking soda will produce less hydroxide ions and will be a weaker electrolyte. So if we look at these colors, these are not random. The universal pH scale, if you were to take pH paper and dip them into each one of these substances, they would reveal the same color. Our acids taste sour. Citrus fruits like limes, lemons, acids, they all have citric acid and ascorbic acid in them. For example, vitamin C. Basic alkaline substances taste bitter. So usually most of our foods fall in the acid category. Basic substances like soap and cleaners are going to feel like soap. To me, I know it says soupy, but we think like soap is slippery. They taste bitter, and they may sting or burn if you were to put them on a cut. Think of like putting a cleaner on a hand that's been cut. When you have an indicator like litmus paper, which can tell you whether you're dealing with an acid or base, it will turn red in an acid and blue in a base. Now, if you have blue litmus paper in a base, it will stay blue. If you had red litmus paper in an acid, it will stay red. Phenolphthalein is an indicator that will turn pink in a basic solution and clear in an acidic solution. Acids and bases, notice they're on either side of the spectrum. It's like a scale. If you add them together, they form a more neutral solution, which is why when you have a stomach ache or acid indigestion, you've got a very acidic environment. If you put an antacid like Tums in there, what you end up doing is bringing your stomach closer to the neutral state it should be at. Now, your stomach is not neutral. Water is neutral. When you have too much acid, it can cause gas and other things. So we put antacids on top to bring the pH up a little bit. This is an example of litmus paper. And here you see red litmus paper has been put into a base and it's turned blue. Blue litmus paper stays blue in a base. In an acid like vinegar, hydrochloric acid, a red litmus paper will stay red and a blue one will turn a red color. You can tell that this is phenolphthalein because when it's hot pink, we put it in a basic solution, and when it is clear, we have an acidic solution. So on your Venn diagram, you need two colors, red and blue. What I've done, we've labeled acids in red and bases in blue, and we put the properties on either side with some examples at the bottom. Now, one thing I want you to notice is the part that says both. When acids and bases dissolve in a solution, they will produce ions. The acids produce hydronium ions, bases produce hydroxide ions, and those ions are what help us conduct electricity. The more ions we have, the stronger the electrolyte will be, the stronger the current will be. So for acids, we wrote them in red because they turn litmus paper red. What that means is red litmus will stay red, blue litmus will turn red. You need to write this down on your paper in red. Their pH levels are below 7. So usually on a regular pH scale, it's 0 to 14. From 0 to 6.9, you will see acids. They're going to produce H3O plus or H plus. Hydronium ions is what we name these in a solution. They're going to taste sour like lemons. And our examples would be citric fruits citrus fruits, tomatoes, soda, coffee, most edible things are going to be acidic. Bases, on the other hand, and by the way, just pause this so that you can write them all. Bases turn litmus paper blue. What that means is if you have a blue litmus paper, it is going to stay blue. If you have a red litmus paper, it will turn blue. Bases turn litmus blue. Their pH levels are anything above 7, so 7.1 to 14. They produce negative hydroxide ions in a solution. Hydroxide is OH minus, so when you see that, if there is more of that in your solution, you've got a basic solution. Bases, which start with a B, also taste bitter. And your examples are your household cleaners. So, your soap, your detergent, your dish soap, your mop cleaner, or floor cleaner, I'm sorry, your spray cleaners, your window cleaner, those are all basic. Your oven cleaner and drain cleaner are very strong bases. Seawater or ocean water is also a little bit basic. And antacids are bases. Those are the ones we use to neutralize our stomach acid. And it doesn't come to a complete neutral, but it will come pretty close. I'm going to zoom out so you can see all of it together.